Welcome back to the classroom. Today we're going to explain the exam starting with the 2013 HSC paper, question 29. This is going to relate to Module 6, Inquiry Question 2 on the motor effect. So let's just go through what the question is and how to solve it. So it says we have a mass of 0.05 and that is lifted at a constant speed. The motor has a coil of 100 turns with a magnetic field strength of 0.1 Teslas. The area is that value there, and the radius of the shaft is that value there. Okay, so we have quite a few different values that we can use to help us work out this question here. So looking at our very first question, it says determine the force needed to lift the mass. So that's our mass object here. How much force do we need to pull that mass upwards? Okay, so to go through the first question, we know that the force required is to go upwards. Now we need to firstly look at what force it needs to counteract. If we look at the mass here, there is a force pulling it down, and that is the gravitational weight force. So the gravitational weight force is pulling our mass down. We can find that based on the mass of the mass object times the acceleration due to gravity, which means in order for us to lift the mass, we need a value that is at the same value of the weight force or higher to pull it up. So the force to pull upwards, force up, will be equal to the opposite component of our gravitational force. So if our gravitational force is, in this case, we had that the mass, so we had that the mass was 0.05 kilograms times, assuming that the acceleration due to gravity is a negative value, negative 9.8. Then the value we have for the force to pull the mass up, if I just put that into my calculator, is 0.49 newtons upwards. So we need at least a force of 0.49 newtons to pull the object up in order to get the mass pulling upwards as well. So that's that question done there. In our second question, it says calculate the minimum current required in the coil to lift the mass. So we've worked out what the mass is. Okay, so we have the force to pull it up, 0.49 newtons. Now, if we look at all the different equations that require the use of magnetic field strength and force, we have F built, and then we have torque, which is BAI. If you take into account the number of coils, you can also write the N at the front. So these are the equations we can sort of deal with. Now, obviously, we don't have the length of string used. If you actually have a look here, we don't have the length of string. We do have the radius and we do have area. So most likely, we need to work out the current based on the torque value. So another equation you can use is the relationship between force and torque. So we know the other formula in relation to torque and force. Torque is equal to the radius perpendicular of the force applied. Okay, in this case you can see our string, our motor, that's perpendicular with our motor, so that's all good there. So what we can do firstly is find the torque value, and we know that the radius, according to our question here, is 0.004. So we put in 0.004 times the force, 0.49. So this will be our value for the torque. So 0.00196, and torque in this case would be, radius is in meters, force is in newtons, Newton meters. Okay, that's our value for torque. Next thing we need to work out is what the current is. So substitute this equation in. I'll do it in a slightly different color, just so you get a sort of second idea of what the follow-up calculations will be. So we now know what the value of torque is. We know the number of turns is 100. We know that the value for the magnetic field strength is 0.1. We want to find the current. And area is 0.0012. Okay, 0.0012. If we rearrange everything onto the one side, so we move all these components over, so we got 0.00196. Give myself a bit of space. 100 times 0.1 times 0.00112. Let's put that into the calculator and see what we get. As you can see, you could always just multiply the numbers first on the current side and then divide it over. Don't have to just move it like it is this way. So the current we have here, I'll give you approximate to 3 sig figures. 0.163 amps, 3 sig figs. And so that is how you do this question here. Alright, so that's how you solve questions related to the motor effect, the relationship between torque and force. If you found exam explanation videos useful like these, please give us a like and have a look at some other videos that's on this channel. Until next time, take care.